So last week we talked about a couple things in regards to the cycle of refrigeration. We talked about latent heat of evaporization. We talked about the latent heat of condensation. We also talked about the higher the pressure, the higher the temperature. These things are all still true, and including hot is attracted to cold. So let's use those basics when we go over the cycle of refrigeration again. So I'm going to go over the basics for components, and then we're going to look at the four components in a residential AC split system right on this video. So let's start. I always like to start at the most important component, which is the compressor. That's the starter upper. That makes the refrigerant move. So we're going to enter the compressor on the lower connection here, right, which is the superheated vapor refrigerant is going to go in here, and then it's going to leave on the discharge line. It's going to leave as a vapor refrigerant too. But because it's a compressor, it pressurizes the existing superheated vapor, which could be under normal working conditions around 65 degrees in the refrigerant line. And it's going to bang it up a good 100, 110 degrees. So it could be 165, 175 degrees of superheated vapor refrigerant here. So it gets even hotter as it comes out of the compressor because it compressed it. Then it's going to enter our condenser right here. And here is our condenser, which has fins all the way around it and copper coils all the way around it. So as it enters the condenser, it's going to go through the latent heat of condensation, which means it's going to turn into a saturated refrigerant. It's going to be 80% vapor and only 20% liquid at the beginning, but after it actually goes all the way around these coils and is diversified into all these coils, spreading it all out, it actually condenses even more. And at the end of the condensation period, it turns into a subcooled liquid refrigerant. So the condenser, during all that time, it rejects heat. So the hot air here that's coming outside is actually sucked in to these condenser coils and then blown out here. So it's rejecting the heat, and it turns into a subcooled liquid refrigerant. Then it goes down, and these two devices are actually in the furnace in the house, right? And as for these two devices, this compressor is actually inside the condenser. But to make the cycle more visible, we've separated them. So then it goes into a metering device as a liquid refrigerant, a subcooled liquid refrigerant. What's the job of the metering device? Or thermostatic expansion valve. There could be many different styles of this. I'm just picking the most popular. Well, it goes into this assembly, and this assembly's job is to drop the pressure. So if you drop the pressure, you're going to drop the temperature also. It's still a liquid though, and it's still going into the bottom of the evaporator coil, which is in the furnace inside the house. And there it becomes also a saturated refrigerant. It was here and is here. But this is where latent heat of condensation took place. Now it's going to be latent heat of evaporation. So this saturated refrigerant, as it goes through all these coils and ends up in the top, is going to end up as vapor. It's going to vaporize, because these coils on this side absorb the heat. So they're going to absorb the heat that's coming in from the ambient room air temperature too. All that heat's going to get absorbed. If it came in as 75 degrees, it'll leave as 65 degrees if that's what you want at your house at. And this degree, so basically it goes through a saturated refrigerant stage, and then latent heat of evaporization takes place, and it turns into a complete vapor on the top. So when it leaves the evaporator, it has to be a vapor. And this device over here, this TXV valve, actually ensures that. It has another copper tube that is tied into the suction line right over here, has a little bulb on it, and it senses what type of, it senses the vapor coming out. It makes sure only vapor is coming out, because if liquid comes out of the suction line and goes into the compressor, it's going to freeze up or ruin the compressor. We do not want liquid in the compressor, only vapor. So that's what comes out of it, and then the vapor goes in. It's a superheated vapor, usually 10 to 14 degrees difference from coming in and out. So if it was 40 degrees here, the refrigerant, it would be about 50 to 54 degrees here, a 10 to 14 degree difference. That difference is usually told right on the compressor. It will say the degrees of difference that you want for the superheated refrigerant. Then it comes out. It could end up here as around 65 degrees under normal summer conditions, but then when it goes into the pressure increases, and if the pressure increases, the temperature increases. So it's going to be even more of a superheated refrigerant here. If it came in 65, may come out 175 degrees. It's going to be super hot. It's going to go back into the compressor. It's going to spread out through the coils, and then it's going to cool down and condense through the latent heat of condensation. And then it's going to become a saturated refrigerant at the beginning, 80% liquid, 20% vapor. And by the time it gets to the end of the coils, and it rejects the heat from outside, it will become a subcooled liquid refrigerant, and there the cycle will return. So that's basically the cycle of refrigeration, how it works. Now we're going to look at what it looks like inside the house.